Hi everyone, this is Miss Moriarty and I'm here to discuss with us our last topic in Unit 5, and that's going to be 5.9, Impacts of Mining. So here we go. So on our slide here, we can see here's an image of different types of mining that we perform all around the world in order to mine for resources such as ores and heavy metals. The first type that we're going to talk about is what's known as surface mining. That's going to be removing minerals that are close to Earth's surface. But when we do that, we oftentimes have to remove large amounts of soil as well as rock, known as overburden, in order to get to the ore underneath. So some examples of that surface mining is things like strip mining. So we can see that in the image over here. That's going to be removing strips of soil as well as rock to then expose the ore. We have open pit mining, and that's going to be the creation of a large pit or hole in the ground and where the surface is going to be visible. Here we have mountaintop removal, so that's actually going to remove the entirety of the top of our mountain, usually using explosives. This can be an incredibly invasive procedure in order to obtain ores. The last example here is going to be placer mining, looking for metals and stones in river sediments here. Now, besides looking at surface mining, we can also see what's known as subsurface mining. So that's going to be mining for resources that are approximately 100 meters below Earth's surface. And as coal reserves get smaller and smaller due to the easily accessible reserves, it becomes necessary to access coal through then subsurface mining, which can be quite expensive. So oftentimes companies will first attempt to do surface mining, but as that ore resource begins to deplete, we have to tap into then subsurface mining techniques. But with subsurface mining techniques, we can see that a lot of mining waste will get produced. And that mining waste includes things like soil and rocks that need to be moved in order to gain access to the ore. Oftentimes, they can be called slag or tailings. Here in the left-hand side of our slide, these are just some pictures of what some surface mining tends to look like. Here, this is a shaft mine and where a hole is going to be dug straight through the overburden, so that's our rocks and our soils there, in order to tap into our ore's supplies, and then it's going to be removed via buckets upward here. We can also see a slope mine, and we're going to see the entry to the ore is going to be dug at that angle there through the overburden and can then be hauled out via carts. As the more accessible ores are going to be mined to depletion, mining operations are forced to then access lower grade ores. Accessing those ores requires increased use of resources that we know are going to increase waste as well as pollution. Economically, we know, though, mining does help to provide low-cost energy, right? We know that fossil fuels we highly depend upon. We mine for those fossil fuels, things like coal, natural gas, petroleum. These are all materials that are necessary to make the products that we know of today. But as we move more towards using subsurface mining rather than surface mining, the cost is going to continue to increase. Now, after we mine for those resources, they need to be refined. And what I mean by that is a lot of those ores are going to consist of impurities called tailings. And those tailings are going to contain toxic materials, things like cyanide, mercury, maybe even sulfuric acid. And that can actually be left behind after a mining project, and they can be left behind in giant piles on the ground and maybe even in ponds in nearby processing plants. We also see that the smelting plants that are required to refine our metals oftentimes emit large amounts of air pollutants because they depend upon fossil fuel use. When we depend upon those fossil fuel use, we can see that it will release sulfur into the air. That sulfur will react with water vapor in the atmosphere, and it will form what's known as sulfuric acid, which can lead to acid rain. It may also contain heavy metals such as lead, cadmium, arsenic, and zinc. And so here's simply just a comparison between our surface versus our subsurface mining. Definitely study this slide, guys, and you want to know the effects on air, water, soil, biodiversity, as well as humans for each and every one. I've definitely seen FRQ questions on this type of slide. But overall, guys, just take note that we know surface mining tends to mine for ores closer to the surface of Earth, which can pick up dust and affect our air quality. We know it contaminates water supplies. We know it will remove soil that may be replaced if potentially reclamation does occur. It obviously alters habitat and destroys surfaces. However, we know it's minimal in its mining process, but air quality, water quality will be adversely affected. But in subsurface mining, because now we're going deeper into the Earth's surface, we have minimal dust, but we know that the machinery we use requires fossil fuels. Here, it can also create what's called acid mine drainage, and I'm going to talk about that in the next slide. Here, we know it requires road construction in order to use a lot of those machineries. That can help to contribute fragments in habitats. And sometimes it can also simply just be an occupational hazard. There's a possibility of death or maybe even chronic respiratory disease. So now some environmental impacts of mining. We know that whatever project we undergo, there's going to be disruption to a large area. Mining can destroy existing vegetation, so the land may be prone to erosion, wind erosion. It can cause air pollution, and water erosion pollutes nearby waterways as well. It can use tremendous amounts of water because that water must be pumped out of the mine to keep it dry, which can overall deplete water needed for potentially irrigation. It will lower the water table in desert ecosystems and will affect nearby fish and other organisms. Environmentalists would like mining companies to re-inject water into the ground after they have pumped it out, which is just simply another use for our water. And the mining of coal, we know, can destroy habitats, contaminate groundwater, and will release dust particles and potentially methane. So there's tons and tons of environmental impacts of mining. And the last one I want to talk about is what's known as acid mine drainage. So in this effect, we see that rocks that are going to be rich in minerals, that are often high concentrations of heavy metals like arsenic and lead, when it rains, that rainwater is going to seep through the sulfide minerals exposed in our mine waste. That sulfuric acid, we know, is then going to be produced as a result of that sulfur reacting with water, and it can potentially dissolve other toxic substances like lead, arsenic, and cadmium. So those acids mixed with those high toxic substances is what creates acid mine drainage, and the mixture of that can be washed into soil as well as water. And so that can affect the numbers of organisms living nearby in waterways, and that rapid drainage during thunderstorms or maybe even spring snowmelt can produce what's called a toxic pulse. So the poisonous water can be particularly harmful to certain organisms like waterfowl, fish, and other wildlife that we find in a given watershed nearby. So now, guys, take a second, pause the video, and see if you can answer the practice FRQ here. Right, an abandoned coal mine site has been found to have very high sulfur levels in its tailings and overburden. Describe one environmental impact of that high sulfur content of the overburden and tailings, and then propose a solution to remedy it. All right, so at this point, you should have paused the video, and let's see if your answer was correct. So here is a possible answer you could have had for this. One environmental impact of our high sulfur content is going to be the acidification of that surrounding soil. Remember, we said coal, tailings, and overburden can dissolve in water, forming that sulfuric acid. This is because acid rain, we know, will seep through the soil and make plant growth very difficult. A possible remedy, however, to this issue is to try and buffer or neutralize that acid with some sort of alkaline or basic substance. A good example of an alkaline or basic substance would be mixing the soil with limestone in order to neutralize the sulfuric acid. Okay, guys, make sure you took notes with this video and please mark this as done.